Today we will be discussing the quotient rule. Now to start off our lesson, let's discover what the quotient rule is. Before I actually give it to you, let's discover what it is. So looking at our h of x here equals f of x over g of x, I can rewrite this as f of x, g of x all to the power of negative 1. Well, g of x to the power of negative 1, sorry. So if we want to take the derivative of h prime of x, we will get this, so we're going to use our product rule to actually figure out what our quotient rule is. So our h prime of x is equal to our f prime of x times g of x to the power of negative 1 plus f of x times negative 1, because we're taking the derivative of our g of x to the power of negative 1, times our g of x to the power of negative 2 times our g prime of x. So I can rewrite this so I have positive exponents. F prime of x all over g of x minus, because of the negative 1 there, f at x times g prime of x all over g of x squared. Find a common denominator, which obviously is going to be our g of x squared. So I need to multiply our first fraction here by g of x. So this is going to be equal to f prime of x times g of x minus f at x g prime of x all over g of x squared. So that's our quotient rule. So if h of x equals f of x over g of x, then h prime of x is equal to f prime of x g of x minus f of x times g prime of x all over g of x squared. So now let's look at our first example. Find the derivative of h of x equals 3x minus 4 all over x to the power of 5 plus 5. So we want to do the derivative of h prime of x. So first we're going to do the derivative of our f of x. So our f of x is always our numerator. So that's just going to be 3 times our g of x, which is our denominator, x to the power of 5 plus 5, minus our f of x minus 4 times our derivative of g of x, or g prime of x, which is just 5x to the power of 4, all over our g of x squared, so x to the power of 5 plus 5, all squared. Now in our numerator, what we're going to do is we're going to expand, so we have 3x to the power of 5 plus 15 minus 15x to the power of 5 plus 20x to the power of 4 all over our x to the power of 5 plus 5 all squared. Collect our like terms, and we have negative 12x to the power of 5 plus our 20x power of 4 plus 15. All over x to the power of 5 plus 5 squared. Now, one thing before we do move on here, I'd just like you to make a little note that whatever makes the denominator equal to 0 is where there is no derivative, as well as a max or min point. Again, whatever makes the denominator equal to 0 is where there is no derivative and a max or min point. So now let's look at our example 2. Find the derivative of h of x equals x to the power of 4 plus 3x cubed all over 2x squared. Again, we're going to use our quotient rule. So h prime of x is equal to the derivative of our f of x, so 4x cubed plus 9x squared times our g of x, 2x squared, minus our f of x, x to the power of 4 plus 3x cubed, times the derivative of our g of x, so 4x, all over our g of x squared, so 2x to the power 2 all squared. Again, similar to example 1, we're going to expand here, so we have 8x to the power of 5 plus 18x squared minus 4x to the power of 5 minus 12x to the power of 4. I'm sorry, this should have been a 4 there at the 18. I think I said that, I just wrote it down wrong. All over 4x to the power of 4. Collect our like terms. So when we actually collect the like terms, we have 4x to the power of 5 plus 6x to the power of 4 all over 4x to the power of 4. Now we can simplify this a little bit further. If we factor out a 2x to the power of 4 in our numerator, we're left with 2x plus 3 all over 4x to the power of 4. Now you can notice here that I can cancel out these x's, and I can also with the constants, and I'd be left with 2 in my denominator. So I would then have 2x to the power of 3 all over 2. Also note here, since we canceled out our x to the power of 4 is there is a hole at x equals 0. So if you were to draw this, make sure that you show that there is a hole at that position. Now example 3, we want to determine the equation of the tangent to y equals 2x all over x squared plus 1 at x equals 0. Now there's two things we need to do. Since we're finding our equation, we need to first find our slope. So that will be our first step here. So we have to find our y prime. So this will be equal to 2 times our x squared plus 5, since I just took the derivative of our f of x and multiplied it by our g of x, minus our f of x times our derivative of our g of x, all over our g of x all squared, so x squared plus 1 squared, and then we can just go ahead and expand and simplify. So we have 2x squared plus 2 minus 4x squared all over x squared plus 1 all squared. So this will give us negative 2x squared plus 2 all over x squared plus 1 squared. Now one other thing is that since we're looking at it at x equals 0, we want to know what a point is from our graph. So we're going to use a point when x is equal to 0, so therefore we have the point 0, 0, as well as we want to know what y prime of 0 is. So we're going to sub in 0 there. So negative 2 times 0 squared plus 2 all over 0 squared plus 1 squared, which we will get this to be equal to 0 plus 2 all over 1, so therefore this will be equal to 2. So that is our slope at y equals 0, so that equals m. So now we can use the fact that we know y equals mx plus b, just a linear equation. So we're going to use the fact that we have our point here, we're going to use the fact we have our slope, and sub it into our equation. So we have 0 equals 2 times 0 plus b. So therefore we get that b is going to be equal to 0. And therefore our equation of this tangent is just going to be y equals 2x. So again, first step, find our slope. Second step, make sure that you have a point. Third step, find the slope at that certain point. And fourth step, solve your equation. And fifth step, put it all together. And for our last example of today's lesson, example 4, we want to find the point or points on the graph f of x equals 2x plus 8 all over the square root of x, where the tangent is horizontal. Again, I always sound like a broken record when we talk about horizontal, but remember our slope will be equal to 0. So knowing that we need to find what the slope is, we know we need to find what the derivative is. So our f prime of x is just going to be equal, we're going to use our quotient rule, it's going to be equal to 2 times our root of x minus our 2x plus 8 times, and do the derivative of our root of x, which is a half, times x to the power of negative a half, all over square root of x squared. So we will have 2 root x minus 2x plus 8 all over 2 root x. Just as a little side note, remember square root of x is the same thing as x to the power of a half. So what I did there is that I just changed our x to the power of negative a half to a positive exponent. And this will all be over x, because the root of x all squared is just going to be left with x. So now I need to find a common denominator here. So my common denominator is going to be 2 root x. So I need to multiply our first part here by that 2 root x. So when I do that, I'm going to be left with 4x minus our 2x plus 8. The reason I put the brackets is around the 2x plus 8 is so that you don't forget to apply that negative to both things inside. All over 2 root x times 1 over x. Expand, collect like terms, so we'll have 2x minus 8 all over 2x root x. I can factor out a 2 here, I'm left with x minus 4 all over 2x root x. Now notice here, factoring worked out nice that I could cancel out a 2. And what I'll be left with is x minus 4 all over x root x. So I now know what my slope is. I also know that I need to set my slope equal to 0. So I have x minus 4 all over x root x is equal to 0. Cross multiply, I get x minus 4 equals 0, and therefore x is equal to 4. But I'm trying to find a point. And since I'm trying to find a point, I now need to know what my y value is. So I just sub that 4 in to my original. So we have 2 times 4 plus 8 all over the root of 4. We get 16 over 2, which is equal to 8. So therefore, the point is 4, 8.